Hello, myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding inter-processor communication and synchronization. At the end of this video, the student will gain knowledge regarding what is the concept of inter-processor communication, what are interconnection structure, what are arbitration mechanisms, and what are the inter-processor synchronization. The topic learning outcome is mapped with the course outcome of summarize the concept of pipelining and inter-process communication for advanced processor design. The topics that are discussed in this video are introduction, inter-processor arbitration, inter-processor communication, inter-processor synchronization, and cache coherence. So, multi-processor systems can employ more than one processor, can be used for the parallel processing. So, more than one task can be simultaneously executed with the help of multi-processor system. This can be achieved either by employing multiple functional units or arithmetic pipelining or instruction pipelining. So, a multiprocessor is a single computer that has multiple processors. These processors can communicate, cooperate to execute the multiple tasks concurrently. So, the communication of the processor takes place either by sending the messages or by sharing the common memory. So, how these processors can be connected is defined with the help of interconnection structure. So, the interconnection structure can have different configuration that is helpful to define the number of transfer paths that are available between the processor and memory in a shared memory system, and how the processor is coupled, either loosely coupled or tightly coupled, can be defined with the help of interconnection structure. Variety of interconnection structures are available. They are time-shared common bus, multi-port memory, crossbar switch, multi-stage switching network, hypercube system. In a time-shared common bus system, multiple processors can share a common system bus with the memory. In case of multi-port memory system, each port can be served as CPU, and the priority for the processor is defined. In a crossbar switch network, the intersection communication path between processor and memory can employ a crossbar switch. So here the switch can define the arbitration mechanism. Multi-stage switching network, a multi-stage switching which is having two inputs and two outputs. So depending upon the multi-stage switching network arrangement, various binary combinations can be generated so that the arbitration of processor can take place. Hypercube system, depending upon the number of processors, 2n paths can be defined and a routing mechanism can be employed in the hypercube for arbitration of the processor. So, in a inter-processor arbitration mechanism, the processor main memory I/O devices can share a common bus. But at the same time, only a single processor or memory can grant the bus at a time. So, the arbitration mechanism is needed to handle multiple requests to the shared resources to resolve multiple contention. So, the design issues of the inter-processor arbitration is processor priority, how to define the priority, either by means of static wave or by means of dynamic wave. So, in case of static mechanisms, the daisy chain and parallel arbitration can be used. In case of dynamic arbitration mechanisms, various algorithms are used to define the priority of the processor while it is in operation. And the fairness, that means the lowest priority processor should never be completely locked out from the bus. So it is having the lowest priority processor can have its fair share towards the common bus. So these are the two design issues of interprocessor arbitration. So three types of interprocessor arbitration mechanisms are available. One is serial or daisy chain arbitration. So in this, the priority of the bus can be defined by means the location of the processor along with the priority line, so that the highest priority bus can share the processor can share the bus. So with the help of daisy chain arbitration, the priority of processor can be generated, and that highest priority processor can share the bus. In the parallel arbitration also, with the two signals, that is bus request and acknowledgement signal, and with priority encoder, the priority of the processor can be defined. So both the serial or daisy chain arbitration, parallel arbitration are the static means of defining the priority of the processor. The third method is dynamic arbitration mechanism, so which is having the facility with algorithms. The processor priority can be fixed while the processor is in operation. So here the dynamic arbitration mechanism can use different algorithms to define the priority. They are generally the time slice, the polling, and LRU and FIFO. So with these mechanisms, the dynamic arbitration can be achieved. But these multiple processors, how they can communicate for parallel execution of the task. So the various processors in the multi-processor system must be provided with a facility of communicating with each other. So the communication path can be established through the portion of the memory or common input-output channel. So the shared memory, how the shared memory can be used for accessing of multiprocessor is a major design issue in the interprocessor communication. So what is shared memory? The sending processor structures a request, a message or a procedure and places it in the memory mailbox. So a portion of the common memory can be used for the shared memory purpose. So the processor that want to share the data item can store in that common memory. The other processor can access via with the help of this portion of the memory. So status bits residing in the common memory, the receiving processor can check the mailbox periodically. So the response time of this procedure can be time consuming. So the mailbox of receiving processor can periodically check, and it has to verify whether the data is available in the common memory with the help of status bits. So it is a time consuming and tedious task. So that sending processor structures a request, a message or processor. So depending upon that, the status bit can be updated. So here a more efficient procedure is for sending processor to alert the receiving processor directly by means of an interrupt signal. So here in the shared memory, all the processors can has to use it to share the common data via the specific portion of the memory. So here these are the multiple processors. Processor 1, processor 2, processor 3, and this is the memory. In this only some portion of the memory can be the shared memory. If data has to be exchanged between these processors, the sending processor can has to place the data in the shared memory. For example, X variable can be shared between the processor. So, after putting the data in the shared memory, the status bits can be updated. The data is available in this shared memory. The receiving processor, for example, P2 is the receiving processor. The processor can has to check its mailbox in a periodic process that regularly whether its mailbox, whether this data is available and it can use this data. So it is a time consuming task. For this verification of data available in the shared memory is a tedious task. The more efficient way of this alerting is the interrupt signal. Whenever the data is placed in the shared memory by the sending processor, it has to raise an interrupt signal so that the receiving processor can receive that alert and the data can be shared with the receiving processor. In addition to the shared memory, a multi-process system may have other shared resources. So, to prevent conflict use of shared resources by several processors, there must be a provision to resolve the conflict of request for shared resources. So, they uses some special configurations to resolve the conflicts that are raised by the processes regarding the shared resources. They are the master-slave configuration. The second one is loosely coupled configuration. Third one is distributed operating system. So these are the three configurations that can be used for shared resource conflict removal. What is the master-slave configuration? So this is the main memory. The processors that are connected to the main memory, one of the processor can be elected as the master processor. The master processor issue the control signals to the slave processors so that they can communicate and coordinate to share the common resources. So this is the master-slave configuration. So the master processor is to manage the entire system. So the files, devices, main memory that are shared can be controlled by the master processor with the slave processors. It maintains status of all the processors, schedule the work to the slave processors. So process scheduling can be controlled and what are the resources that are shared, those status bits can also be maintained by the master processor. The master processor is also responsible for storage management, and this type of configuration is suitable for computing environment where processing time needs to be divided between front-end and back-end processor. So, the two-tier architecture applications generally used this master-slave configuration. So, where the master processor can have the storage maintenance capacity and issuing of control signals and maintenance of status bits regarding the resource sharing, and the slaves can coordinate with the master for executing the task. What are the disadvantages? So it is reliable as single processor system. If the master processor fails, the entire system fails. Okay. What are the disadvantages of this master-slave configuration system? So, the reliability is quite complex in the master-slave configuration. Why? Because if master processor fails, the entire system can be failed. The master processor itself maintains and controls the task. So if that processor fails, the entire system can fail. It creates more overhead charges. Why? Because the slave process will free and master process can assign another task. So the valuable time of processing can be wasted in assigning and scheduling the task to the slave process. After each task completed by the slave processor, it interrupts the master processor operating system intervention. So here the slave processor can be waited to execute the task. So these are the disadvantages of the master-slave configuration. Next is the loosely coupled configuration. So in the loosely coupled configuration, each processor can execute the operating system routines as it referred as a separate operating system organization. So each processor can be independent operating system. So each processor control its own resources and it also issues the command and managing the status bits of the resources. So each processor can also communicate and cooperate with each other. When a job is given, it is assigned to one processor and that processor works on the task till its completion. So there must be a global table to indicate which processor has been on what task. So each processor can have its own operating system, can have its own scheduling mechanism, and each processor capable of updation of status bits regarding the resource sharing. So the dedicated global tables and one sophisticated operating system can be needed. So based on this global table updation, each processor can assign a specific task so that the processor can execute that particular task in loosely coupled configuration. So here this is the configuration of loosely coupled processor. So processor 1, processor 2, processor 3, which is having the main memory and sharing the I/O devices. They are independently working and can be communicating and coordinating with other processors. Next type of configuration is symmetric configuration. In a symmetric configuration, process scheduling is decentralized. So distributed operating system can be needed for symmetric configuration. A single copy of operating system and a table listing each processor in its status is stored in the memory. So it can be accessible to the other processors. A common centralized table of resources can be maintained and a copy of operating system can maintain these global tables so that each processor can use the algorithms to decide which job to run the next. So centralized operating system can maintain the global tables so that each task can be allotted for the processor and the processor can be worked over it till its completion of the task. So here I/O devices and main memory, all the processors are sharing it. So there is a table that has to maintain by the operating system. The operating system can perform the scheduling of the processors. What are the advantages and disadvantages? So this symmetric configuration is more reliable and resources can be more effectively used and it can well manage load balancing mechanism can be there between the jobs and if at all one processor fails, a graceful degradation of system can be maintained. The other processor can take the load of the processors and complete the task. So these are the advantages of the symmetric configuration. The disadvantages are it increases the chances of conflict between the processors. It is the most difficult configuration to implement. Why? Because global tables can be maintained in this type of configuration. So how processes can be communicated we discussed. So while sharing the resources, how process synchronization can be achieved. So in the inter-processor synchronization, the instruction set of multi-processors contains the instructions that are used to implement communication and synchronization between cooperating processors. So instruction set architecture of the particular processor can contain the instructions how it has to cooperate and communicate with the other processes. So how it can exchange the data between different processes. So synchronization refers to special case where the data used to communicate between processor is with the help of control information. So how data exchange can be taken place between multiple processes with the help of control information, special instructions that are available in the instruction set of the instruction set architecture of the processor. Synchronization is needed to enforce the correct sequence of the process and to ensure mutually exclusive access to shared writable data. So what is mutual exclusion? We'll discuss. So what are the mechanisms that are available to maintain this inter-process synchronization? So low-level primitives that are supported by the instruction set architecture can implement directly with the help of hardware for process synchronization. So these primitives are the basic mechanisms that enforce mutual exclusion for more complex mechanisms implemented in the software. So with these hardware mechanisms, the mutual exclusion can be possible. That the resource can be used by one processor, the other processor cannot use that resource till its completion. The hardware mechanism is the major hardware mechanism that can be used for process synchronization is the semaphore. Now we have to discuss what is mutual exclusion. So a properly functioning multi-processor system must provide a mechanism that will guarantee orderly access the shared memory and other shared resources. So multiple resources can request the shared resources. So here the orderly allocation of resources to the processor can be done with the help of mutual exclusion. So the mutual exclusion is necessary to protect data from being changed simultaneously by two or more processors. If same data is shared by multiple processors, there is a problem of data inconsistency. So the data values can be shared so that inconsistent data can be available to other processors. To avoid this, mutual exclusion can be used. So to support mutual exclusion, critical section is one of the feature. So it is a program sequence that must complete execution before another processor access the same shared resource. So the section of the program can be accessed by one processor at a time. That is the critical section. So what is mutual exclusion? What is the critical section? We will discuss with an example. For example, if in a shopping mall, you can use the trial room for whenever you are buying the clothes. So this is the trial room and the status of the trial room is vacant. So two persons are waiting to use this trial room. So one boy A and girl B. So initial state can be the trial room, it is the critical section. So after some time, boy A entered into the room and using the trial room. So boy A is using it. The status can be indicated to other that are waiting here with the occupied status. So that girl B can be wait until vacant status can be indicated and boy A come out of this trial room. So boy A is going out, girl B is entering the room and by seeing the vacant status of the room. So this is the critical section that can be shared with the mutual exclusion, so that the process can be synchronized one after another, can use the shared resources. So another example is the signaling of the railway can also be used, the concept of mutual exclusion and also critical section. So the basic method here used to control this process synchronization is the semaphore. So which is used to indicate the correct status, how the critical section can be used by the processors. It is a binary variable. So here this is the status, which is having two states, whether it is vacant or occupied. Depending upon these values, the processors can enter in the critical section and using it. So binary variable that indicates the usage status of the critical section is generally the semaphore. With the semaphores, the process synchronization can be achieved. For example, if we take the railway signaling, so these are the rail and one signal is here. If it all the rail that want to enter into this critical section, this is the critical section. One rail here to enter into this and one rail is using this critical section. So when the train enter into these rails, the signal here has to be raised. After seeing this signal here, raised signal, the second rail that is used this rail section has to wait here. This rail can, whenever it leaves the critical section, the signal can be lowered here so that the next train entering into the critical section understood that the critical section is free and it can enter and use the critical section. So in this way, the semaphores can be used in many situations for process synchronization when the same section, when the common resources are used by multiple processors. So a semaphore is a binary variable and it is often to indicate whether or not processor is executing a critical section. So the indication can be denoted with the help of semaphore, which is a binary variable. So testing and setting the semaphore itself a critical operation. So these can be performed with indivisible operation. So a semaphore can be initialized by means of test and set instruction in conjunction with hardware lock mechanism. So whenever one resource is using the critical section, the hardware lock can be provided so that other processor cannot use the common critical section. So the instructions that are used to test and set the semaphore are the memory semaphore that can be used with that is assigned to a register, and the one value that is used can be stored in the memory location. The binary value 1 means the critical section is used by the other processor. After using and completion of its task of critical section, the processor has to be update the status with 0 so that other processor can use the critical section. So test and set that are used for the semaphore can be indicated with the RTL like this. What is cache coherence? Cache coherence is the consistency of shared resource data that ends up stored in multiple local caches. So each processor that is in the multi-process system have a cache. Cache is a high-speed small memory that can be placed between the processor and the main memory. So multiple processors can have multiple cache. If they are sharing the common set of data, then there is a problem of data, inconsistent data. So data inconsistency, how it can be avoided, we have to see. When clients in a system contain caches of common memory resource, problems may arise with inconsistent data. So this is the major problem of cache coherence, which is particularly used the CPUs in multi-processing system. Now with an example, we will discuss the cache coherence. So more than one CPU can be employed in the multiprocessor system. Each processor can have its own cache. Cache 1, cache 2, cache 3. And in the main memory, there is a variable having the X is having the value 24. And it can be shared between these processors. For example, here cache 1 is using X value 24. Cache 2 is also using the X value 24. While during execution, cache 1 is performed a write operation on the X and it can update the value of X to 60. But cache 2 is using the value of X as 24. But its latest value is 60. This latest updation should not reflect it here. So thereby the inconsistent data problem can be erased. So the cache coherence is used to maintain consistency of shared resources between multiple processors. So in this example, if it all processor 1 read the X, so it can obtain 24 value. And if it all processor 2 can also be read the X value. So it can contain the value X value 24. Again processor write X value to the 64. So the updation of shared resource can be taken place at the cache 1. So memory and processor can think that X value can be 24, which is the older value. But processor 1 is thinking that X's value is updated and its value is 64. So here data consistency problem is raised. So cache coherence has to be avoided these days data inconsistency problem at different levels. So every write operation appears to occur instantaneously. So during write operation, more care can be taken place. All processors see exactly same sequence of changes of values for each separate operand. During updation and write operation, the processors can follow same sequence of operations. Different processors may see an operation and assume different sequence of values. This is known as non-coherent behavior. So, various protocols can be used to resolve this problem. Those protocols are cache coherence protocols. The general protocols are MSI protocol, that is modified, shared, invalid. So, if data value can be modified and it can be shared, the data can be the invalid. MOSI protocol, modified, wound, shared, invalid. So after modification, data can be shared, it can be invalid. MESI, modified, exclusive, shared, invalid. MOESI, modified, wound, exclusive, shared, invalid. So all these are used to avoid the data inconsistency problem, which can be taken care morely. Strict concentration can be taken over the updation or write operation of the operand. If it all the operand is updated or modified, that is shared, the data can be the invalid data. And coherency mechanisms are employed to resolve these data inconsistency problems. So, three types of mechanisms are employed. One is dictionary based system, next one is snooping, third one is snarfing. What is a dictionary based system? In a dictionary based system, the data being shared is placed in a common dictionary. So, what are the common data that is sharing? That must be placed in the common dictionary, and this common dictionary can be maintained by the all cache of all the processors. The dictionary acts as the filter through which the processors must ask permission to load an entry from primary memory to its cache. If it all these common resources can be used by the processor, they require the special permission so that the dictionary values can be loaded into that particular cache of the processor. When an entry is changed, the dictionary either updated or invalidates other caches with that entry. So that when it is updated, the special care can be taken care. The other process uses the same data. The invalid operation can be applied. Otherwise, if it has valid data updation, it can be updated in the dictionary, common dictionary. The second method of coherency problem is the snooping. It is introduced in 1983. Snooping is a process where the individual caches monitor address lines for access to the memory locations that they have cache. So the address positions of the memory can be monitored. It is called a write invalid protocol. So the monitoring can be take place with the help of write invalid protocol. When a write operation is observed to a location that a cache has a copy and the cache controller invalidates its own copy of the snooped memory location. So during write operation, if it are valid copy, that can be controlled with the help of snooped memory location, that copy can be maintained in that memory location. Otherwise, it invalidates the operations of all the processor caches. So this method is called the snooping. Next method of coherency problem is snarfing. Snarfing is a mechanism where a cache controller watches both address as well as the data in an attempt to update. So here both address lines as well as data can be monitored in case of snarfing. So here a memory location when a second master modifies the location in the main memory. So more care can be taken care regarding the modification of the data. When a write operation is observed to a location that a cache has a copy of the cache controller updates its own copy. So during modification, it has to update its own copy of data to avoid the data inconsistency problem. So these are the various mechanisms of cache coherence which is used to mitigate the data inconsistency problem that is raised during the sharing of common resources between the multiple processors. And process synchronization can be achieved with the help of mutual exclusion critical section and can be indicated with the help of the semaphore. And these are the references used in this video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.